All right, starting on page 7, we are dealing with perpendicular and parallel lines. So for perpendicular, you need to remember that to get a perpendicular slope, you have to flip the numbers in the numerator and denominator and switch the signs. So if your slope was positive, you'd have to make it negative, and if your slope was negative, you'd have to make it positive. Okay. The other thing to remember is that for parallel lines, parallel just means the same slope. Okay, so that's when your lines never touch or cross. They are exactly the same slope. Okay, so the first task is to find the slope that they actually gave you. So 53, go back and look at those equations on page 5 if you don't remember which number is the slope. 54, go ahead and look on that page also. That's when you rearrange. So you've got to get this into y equals first before you can pick out your slope. Your slope is not -4. You have to rearrange. This is in standard form. And 55, this is the one I'm going to do for you. So we want to find the line that's perpendicular to the y-axis. So if you think about your graph, your vertical line is the y-axis and your horizontal line is the x-axis. So when they give you this point, you want to say, okay, 5, 1, that could be a point like this. And we want to have this line be perpendicular to my y-axis, which means that my line needs to go horizontally through that point. And for a horizontal line that has a 0 slope and my line is always y equal to whatever number it passes through. My y here is 1, so on 55, this is all I need. So on 55 and 58, if you're ever asked about finding something parallel or perpendicular to the y or x-axis, your final equation is always going to be y equals a number or x equals a number, but I would strongly suggest you draw a mini graph or something and sketch it off to the side. That way you have a better idea what you're looking at. Okay. And I changed my mind, so I will work 54 for you, and then you can go ahead and finish these. So again, we have to rearrange this. So opposite A is -3 over B, which is -4, and that's my x. And then if I were to finish this equation, I would have -9 over -4. Okay, so this equation is the same as having y equal to +3 over 4x plus 9 over 4. So this is my equation that I'm starting with. So my given slope is 3 over 4. Okay, so if I'm given a slope of +3 over 4, we need to switch the signs. So this now becomes negative. Okay, and we need to flip those numbers. So right now 3 is on the top, 4 is in the denominator, so we need to switch it. So we're going to have 4 divided by 3. Okay, from here we need to use point slope form and rearrange. So y minus y1, in this case my y1 is 5, so y minus 5 is equal to my perpendicular slope, which is -4 over 3. And then I have x minus, sorry about that, I'm just so popular. And then my x here is 2, so x minus 2. And for me, this is good enough. This equation is definitely perpendicular and it goes through that point. Okay, so remember to use point slope form on these. You only need to rearrange one more for perpendicular, and for parallel, remember that same slope, so y'all should be able to do those 3. 59 and 60, I talked a lot about parallel and perpendicular. Look at the top of your page if you're not sure what to write. All right, for 61 through 64, we're setting up a proportion. So it says if there are 304 total formulas, how many formula charts are there if each chart contains 13 formulas? Okay, so anytime you see directly proportional, you know that you can probably solve it with the proportion. So if we know that there are total 304 formulas, so I'm going to put an F for formula, and we know that if each chart contains 13 formulas, that means we have 13 formulas for every one chart. Okay, so we just need to solve for our variable x over here. So you cross multiply, 1 times 304 is 1, and then in your calculator you can check 304 divided by 13. And that'll be equal to 23.38. So you can say we would need at least 23 or 24 charts. For 65 on, you're writing two equations, so you're going to have to take them as a case-by-case kind of thing. So the first one says the length of a rectangular playground is 4 meters less than 3 times the width. The perimeter is 64 meters. Write two equations that could be used to solve the system. So the first part is I want to just take that first sentence and make that into one of my equations. So it says the length, that's an L, of a rectangular playground is 4 meters. Every time you see is, it's going to be equals, and it says is less than, and that'll be an inequality. So is equals 4 meters less than 3 times the width. Less than means subtract. 3 times means we're going to be multiplying. So we're doing 3 times the width. So this whole line right here, 3 times the width, is the same as me saying 3W. And then we have 4. And less than, it is subtraction, but if I put 4 minus 3W, that would be incorrect. Less than means you need to switch the order, so it's 3W minus 4. So that's my equation for my length. The second part is it's talking about perimeter. So my perimeter is 64 meters wide. And if you look at a rectangle, we have, and pretend that's a rectangle, we have a length, and we have two widths. So I could say 2W plus 2L equals 64. So 2L plus 2W equals 64. Okay. And then just to get you started for 66, it says Jose has $4.10 in dimes and quarters. He has 6 more dimes than quarters. Write two equations that would be used to solve this system. So when you're going through these, you're generally going to have one equation for the total. So here my total is 4.1. And what are the things I'm combining? Right here, dimes and quarters. So those are going to be my two variables. And then you'll need to figure out specifically what's going on between the dimes and quarters. So if we have 6 more dimes than quarters, this is going to be what you write as your second equation. So try and look for one equation to be a total of what you're adding up, and then figure out what's going on specifically. But like I said at the beginning, you're going to have to take it as a case-by-case basis.